Hi students, today we are going to discuss vector triple product. Vector triple product by the definition, vector triple product for any three vectors, A vector, B vector, C vector. Then the vectors A vector cross B vector cross C vector is called a vector triple product. It's called a vector triple product. For any three vectors, A vector, B vector, C vector be a non-zero vectors. The vectors A vector cross B vector cross C vector is called a vector triple product. Already you know scalar triple product is for any three vectors A vector dot B vector cross C vector is called a scalar triple product. That is a dot is a scalar triple product. It is A vector cross B vector cross C vector is called a vector triple product. How to find the vector triple product? A vector cross B vector cross C vector is A vector cross B vector cross C vector equal to, first now find bracket value B vector cross C vector. First now find B vector cross C vector. B vector cross C vector is B vector cross C vector. Two vectors, vector product of two vectors by using determinant form. By using determinant form, I vector, J vector, K vector. And first one write in a component of B vector is component of B. And next one the component of C. Getting a one of the vector B cross C. The next one find A vector cross B cross C. Getting the one of the vector. Last one find A vector cross B vector cross C vector equal to determinant of. A vector is one of the vector, B cross C is the one of the vector. Vector product of two vectors. Vector product of two vectors. I vector, J vector, K vector. The component of A and the component of B cross A. Component of B cross A, getting the vector. That is a vector triple product. Vector triple product is A vector cross B vector cross C vector is, first now find bracket value B vector cross C vector. B vector cross C vector is vector product of two vectors by using determinant form I vector, J vector, K vector and component of A and component of C. The next one find the total value A vector cross bracket of B vector cross C vector is I vector, J vector, K vector. Then vector product of two vectors, the component of A and the component of B vector cross C vector. The next one, now expansion of vector triple product. Expansion of vector triple product is A vector cross B vector cross C vector. Now expansion of vector triple product is A vector dot C vector. A vector dot C vector into B vector. A vector dot C vector into B vector minus A vector dot B vector. A vector dot B vector into C vector. That is a vector triple product by the expansion. How to find the expansion is, now consider the bracket. Now consider the vector in a bracket B vector cross C vector. B vector is a middle vector. B vector is the middle vector and C vector is non-middle vector. B vector is middle vector and C is non-middle vector. This implies B vector is a middle vector. Middle vector. That is a middle vector is B vector. Middle vector. The next one A dot C. A dot C is, that is a lambda. Where lambda is multiplication of dot product of two vectors other than middle vector. Where lambda is dot product of two vectors other than middle vector. Lambda of middle vector minus mu of non-middle vector. Minus mu of non-middle vector. Where mu means dot product of two vectors other than non-middle vector. Dot product of two vectors is mu other than non-middle vector. That is a expansion of vector triple product is A dot C. A dot C is lambda. A dot C into B is a middle vector minus A dot B is lambda is mu. A dot B into C is non-middle vector. That is a expansion. Now write in A vector cross B vector cross C vector is in vector triple product write in A cross B cross C vector. That is a vector triple product. A vector cross B vector cross C vector is also a vector triple product. Now write in that is a middle vector. Middle vector B vector. B vector. Middle vector is B vector. Next one, when dot product of two vectors other than middle vector is A dot C. A vector dot C vector into B vector minus non-middle vector is A vector. Non-middle vector A vector. Then dot product of two vectors other than non-middle vector is B dot C. This B dot C into A vector. A dot C into B vector minus B dot C into A vector. That is the expansion of vector triple product. The next one, theorem 6.8, Jacobi's method. Jacobi's identity. Jacobi's identity is for any three vectors. For any three vectors, A vector, B vector, C vector. That is A vector cross B vector cross C vector plus B vector cross A vector cross C vector or C vector cross A vector plus C vector cross A vector cross B vector equal to 0. Then the value equal to 0, that is Jacobi's identity. A vector cross B cross C plus B vector cross A vector cross C vector plus C vector cross A vector cross B vector equal to 0 is, that is a Jacobi's identity. The next one, Lagrange identity. Lagrange's identity for any four vectors. For any four vectors, A vector, B vector, C vector and D vector. For any four vectors. Now find A vector cross B vector dot C vector cross D vector. That is a Lagrange identity is scalar product of four vectors. Scalar product of four vectors. That is a Lagrange identity is scalar product of four vectors. A cross B dot C vector cross D vector. A vector cross B vector dot C vector cross D vector. Now write in determinant form. In determinant form. The first one multiply dot product of A dot C. First one A vector dot C vector. Next one A vector dot D vector. A vector dot D vector. And the second row B vector dot C vector. B vector dot C vector. Next one B vector dot D vector. B vector dot D vector is Lagrange identity or scalar product of four vectors. Scalar product of four vectors, that is called a Lagrange identity or scalar product of four vectors is A vector cross B vector dot C vector cross D vector is first row is A dot C, A dot D, and second row B dot C, B dot D. Vector triple product based on exercise problem, exercise 6.3. First one, if A vector is I vector minus 2j vector plus 3k vector and B vector equal 2i vector plus j vector minus 2k vector, C vector equal to 3i vector plus 2j vector plus k vector. Find first one A vector cross B vector cross C vector. The first result. Second one A vector cross bracket of B vector cross C vector. First now find first one result. Given A, B, C. Now first to find A vector cross B vector cross C vector. First now find A vector cross B vector. That is a bracket value. A vector cross B vector. A vector cross B vector is a vector product of two vectors. Vector product of two vectors, already you know, vector product of two vectors is by using determinant form. That is a determinant of first write in I vector, J vector, K vector. The next one, component of A. Component of A is 1, minus 2, 3. And the component of B is 2, 1, minus 2 equal I vector into 2 2s are minus in the minus plus 2 2s are 4. Next formula is minus 1 3s are 3. Next one, minus J vector into, there is a minor matrix. 1 into minus 2, 2 3s are minus 6. Next one, plus K vector into 1 1s are 1, getting a minor matrix. This one 1 1s are 1. Formula is minus 2 into minus 2, minus 4, minus half, minus plus 2 2s are 4. That is equal 4 minus 3. 4 minus 3 is 1. 1 and I vector is I vector. The next one, minus 2, minus 6, minus 8, minus half, minus plus 8 J vector. 8 J vector plus 4 plus 1, 5 K vector is A vector cross B vector. First now find A vector cross B vector value, I vector plus 8J vector plus 5K vector. Next one, find the total value. A vector cross B vector cross C vector. Next to find A vector cross B vector cross C vector equal to. Already find A vector cross B vector is, that is a one of the vector, I vector plus 8J plus 5K, and the C vector is the one of the vector, and vector product of two vectors. Vector product of two vectors is using determinant form, I vector, J vector and K vector. The component of A cross B is 1, 8, 5, and the component of C is 3, 2, 1 equal. Now expanding the determinant, I vector into 8 ones are 8, 5 twos are 10, minus 10. Next one, minus J element, taking the element J minus J, column under row are eliminated, getting the minor matrix. 1 ones are 1, minus 15, 5 threes are 15. Next one, taking the element K plus K vector into column under row are eliminated, getting the minor matrix. 1 twos are 2, minus 8 threes are 24. 8 threes are 24. The next one equal 8 minus 10. 8 minus 10 is minus 2, minus 2 I vector. The next one, 1 minus 15. 1 minus 15 is minus 14, minus half, minus plus 14 J vector. 2 minus 24. 2 minus 24 minus 22 plus in the minus 22 K vector. That is A vector cross B vector cross C vector. That is the answer. First one, A vector cross B vector cross C vector equal to minus 2i plus 14j minus 22 K vector. That is first answer. The next one you find the second one, A vector cross B vector cross C vector. A vector cross bracket of B vector cross C vector. First one you find bracket of B vector cross C vector. B vector cross C vector is vector product of two vector by using determinant form. The component of B and the component of C getting a one of the vector. And A vector, the total value, A vector cross B cross C. A vector is one of the vector and B cross C is the one of the vector. Vector product of two vector by using determinant form getting the vector. That is the second result yourself. Next problem. Second problem. For any vector A vector, prove that I vector cross A vector cross I vector plus J vector cross A vector cross J vector plus K vector cross A vector cross K vector equal to 2A vector. We have to prove LHS equal to RHS. LHS equal to RHS for any vector A vector. For any vector A vector. Now I am taking LHS. LHS, left hand side. Left hand side is first one I vector cross A vector cross I vector. First now find one by one. First one I vector cross A vector cross I vector equal I vector cross A vector cross I vector by vector triple product expansion. Already you know vector triple product expansion is first one I dot I middle vector into dot product of two vector other than middle vector. The first one I dot I vector dot I vector into A vector minus non-middle vector into dot product of two vectors. I vector dot A vector into I vector. First one I dot I into A middle vector. The next one non-middle vector is non-middle vector I vector. I vector dot A vector into I vector. For any vector A vector, let A vector equal to A1 I vector plus A2 J vector plus A3 K vector. For any vector A vector, now I am taking the A vector equal to A1 I vector plus A2 J plus A3 K vector. First one I vector cross A vector cross I vector, this one result equal. First one I vector dot I vector value 1 into A vector is A vector minus I vector dot A vector. Here A vector is A1 I vector plus A2J plus A3K. A1 I vector plus A2J vector plus A3K vector into I vector. It's equal A vector minus first one I vector dot product of A1 I vector plus A2J plus A3K. Dot product of two vectors. Dot product of two vectors is I dot I value 1, J dot J value 1, K dot K value 1. Already you know. First one I vector dot A1 I vector. This value is 1. 1 into A1 is A1. Otherwise I dot J value 0. I dot K value is 0. Getting A1 only. A1 into I vector. A1 into I vector. That is the result is A vector minus A1 I vector. That is one of the result. I vector cross I vector is A vector minus A1 I vector. The second result J vector. The second one J vector cross A vector cross J vector equal to now expansion of vector triple product J vector dot J vector into A vector minus J vector dot A vector into J vector equal J dot J value 1 into A vector is A vector minus J vector into dot J vector dot product of A vector is A1 I vector plus A2 J vector plus A3 K vector into J vector. That is equal A vector minus J vector dot product of A1 I plus A2 J A3 K dot product is J dot J values is 1. Otherwise 0. J vector 1 into A2 is A2. This J vector A2 J vector. This second one. And the third one K vector cross A vector cross K vector. That is equal by using the expansion K dot K. K vector dot K vector into A vector minus K vector dot A vector into K vector. That is equal K dot K value 1 into A vector is A vector minus K vector dot A vector is A1 I vector plus A2 J vector plus A3 K vector into K vector. That is equal A vector minus K vector dot K vector value 1. Otherwise 0. 1 into A3 is A3. A3 into K vector is A3 K vector. Now add the three results. Now adding the three results. The first one I vector cross left hand side I vector cross A vector cross I vector plus J vector cross A vector cross J vector plus K vector cross A vector cross K vector equal to, add the three result. The first one A minus A1 I vector, and the second one A vector minus A2 J vector, and the third one A vector minus A3 K vector. Adding the A, first one A 3A vector being minus A1 I vector minus A2 J vector minus A3 K vector. Add the value, taking minus is common, the inside A1 I vector plus A2 J vector plus A3 K vector, that is equal 3A vector minus A1 I vector plus A2 J vector plus A3 K vector is already A vector. A vector is A1 I, A2 J, A3 K. Now substitute A vector. 3A vector minus A vector. 3A minus A. This 2A vector. Therefore the result I vector cross A cross I, J vector cross A vector cross J vector, K vector cross A vector cross K vector equal to 2A vector. Hence it proved. Next problem, third one. Prove that box product of A vector minus B vector, comma, B vector minus C vector, comma, C vector minus A vector equal to 0. You have to prove the result equal to 0. The first one LHS, the left hand side is box product of. It is a box product of A vector minus B vector, B vector minus C vector, C vector minus A vector is a box product. Then box product of A vector, B vector, C vector. Already you know the box product of ABC is the box product of A vector, B vector, C vector is a scalar triple product. Box product of A vector, B vector, C vector is a scalar product of three vectors. Scalar product of three vectors is, now we write in A vector dot B vector cross C vector, or A cross B dot C vector. Write it one. Method. Box product of ABC is A vector dot B vector cross C vector. Now assign A minus B is A vector, B minus C is B vector, C vector minus A vector is C vector. Now write in a scalar triple product A vector dot B vector cross C vector. A vector is A vector minus B vector, A vector minus B vector dot B vector cross C vector, where B is B vector minus C vector, B vector minus C vector cross C vector is C vector minus A vector, C vector minus A vector. That is equal, the first one A vector minus B vector dot, first multiply this one B vector cross C vector, first one multiply B vector cross C vector, B vector cross C vector. Next one plus and minus minus B vector cross A vector, B vector cross A vector. The next one minus C vector cross C vector, C vector cross C vector. Next one minus in the minus plus C vector cross A vector, C vector cross A vector. That is it. The first one B vector cross A vector minus B vector cross A vector. The third one C vector cross C vector. Vector product of two vectors are equal vectors. C vector cross C vector value is, that is the value equal to, this value equal to 0. This value is 0. The next one, now dot product of these vectors. Now multiply dot product of A vector, these terms, all terms. The first one multiply A vector dot B vector cross C vector, A vector dot B vector cross C vector. The next one minus B vector cross A vector is, write in interchange A vector cross B vector, A vector cross B vector plus A vector dot, that is a interchange, the result is A cross B, minus of B cross A, that is a commutative properties. Vector product is not commutative, A cross B is not equal to B cross A, but A vector cross B vector is minus of B cross A. That is, write in A cross B vector, A vector cross B vector. This result is 0. The next one plus A vector dot C vector cross A vector, C vector cross A vector. The next one minus of B vector dot B vector cross A vector minus, already to change the result is this one is plus A vector cross B vector. This result equal to A vector cross B vector. The next one B vector dot A vector cross B vector. Next one minus B vector dot C vector cross A vector. C vector cross A vector, that is the result. The first one, A vector dot B vector cross C vector is a scalar triple product. A vector dot B vector cross C vector. A vector dot B vector cross C vector is a scalar product. This scalar product is written in a box product of ABC. Box product of A vector, B vector, C vector. This one, A vector dot A vector cross B vector. A vector cross B vector. A dot A cross B is box product of three vectors. A, that is A vector dot A vector and B vector. Box product of A vector, B vector and equal vectors. Equal vectors values is, this value is 0. This value 0. The next one, A dot C vector cross A vector. A vector, that is a box product of A, C, A. Equal vectors. A and A are equal vector, that is the value is 0. This value is 0. The next one, minus B vector dot B vector cross C vector is, then box product of B, equal vectors, this value is 0. Or minus 0 plus 0. Minus 0. This result, B dot B equal vectors values is 0. The next one minus B dot C vector cross A vector. Now writing the box product of A vector, B vector and C vector. That is equal. The first one, box product of A vector, B vector, C vector minus and box product of A vector, B vector, C vector. That is A box product of ABC minus box product of ABC. This result equal to 0. Therefore, and box product of A vector minus B vector, B vector minus C vector, C vector minus A vector equal to 0. Hence proved.